We're asked to find the values of these four trigonometric functions, and I think furthermore we're supposed to write them as their exact answer, so not just plugging them in a calculator. So to do that, we will want to draw the angles. And when you draw an angle in the x and y grid, this is the initial side. This is a 0-degree angle. This is 45. This is 90. This is 135. This is 180, right? So this is 360. So 210 degrees is a little bit past 180, but not quite past 270. So there's the terminal side of 210 degrees. So I've drawn that angle. And what you want to do is construct a triangle with the x-axis. Okay? And then to fill out that triangle, you need to know the degrees right here. This is 30 degrees, right? Because if this is 210 degrees all the way around, then this is 180. You've got 30 more to get to 210. So now we know the angle there. This is one of our special triangles that in trigonometry we'll usually want to have memorized. A 30-degree angle inside a right triangle, if it has a hypotenuse of 1, then the opposite of 30 degrees is going to be 1/2. And then the opposite of 60 is going to be square root of 3 over 2. Okay? That's just one of the special triangles that we memorize. That way we can always get the exact answers. And the hypotenuse of 1 comes from that whole idea of the unit circle. We're just choosing a circle that's easiest to work with. If we have a radius of 1, that makes all the other measurements a lot easier to work with. So it could be, you could do a circle that has 2, but the ratio would still be the same. So either way, this is a triangle you want to have memorized. We draw the angle inside the unit circle. That way we have 1 for a hypotenuse, and that way we get to use these side lengths. So opposite of 30 degrees is 1/2. Opposite of this 30 degrees is 1/2. And I'm going to label it negative because we're going down on the y-axis, right? This is -1, -2, -3. That's why I changed that to a -1/2 instead of +1/2. And then if we made a right triangle, that's 30 degrees, so this is 60 degrees. So we could label this other side. I mean, this one's 1, this one's -1/2, and this one's going to be negative square root of 3 over 2 for the same reason. We're on the negative side of the x-axis. And now that it's labeled, we can use all these trig functions. Cosecant is the reciprocal of sine. So if you can figure out what sine is from 30 degrees perspective, then just flip it, and you've got cosecant. Right? So cosecant 210 is the reciprocal of sine, or in other words, it's the hypotenuse divided by the opposite. And so if we're talking about this triangle, the hypotenuse is 1, and then the opposite of this reference angle is -1/2. And if you do that fraction arithmetic, that means this is -2. Okay, 1 divided by -1/2 is -2. And then same thing with secant. Secant is the reciprocal of cosine. In other words, it's hypotenuse divided by adjacent. Or we could just figure out what cosine of 210 degrees is. So cosine is the adjacent side divided by the hypotenuse. So cosine of 210 is negative square root of 3 over 2. So that means secant of 210 is -2 over square root of 3. Or you might see it written like this, -2 square root of 3 over 3. Same thing, because I just multiplied the top and the bottom by square root of 3 here. So secant 210 is -2 square roots of 3 over 3. And then tangent is the opposite over the adjacent. So tangent of our reference angle, the opposite's -1/2. And that's being divided by the adjacent, which is negative square root of 3 over 2. So negative divided by a negative makes a positive. And then we can flip and multiply this second fraction. So that's going to be times 2 over the square root of 3. So these can cross cancel. So negative times negative makes a positive 1 over the square root of 3. Or if we rationalize the denominator, that's square root of 3 over 3. So tangent is square root of 3 over 3. And then you probably know what cotangent is. It's just the reciprocal, right? Cotangent would be 3 over the square root of 3, which is the same thing as 3 square roots of 3 over 3, because I just multiplied the top and the bottom of this fraction by square root of 3. So there's your 4 answers for those. Let me go see if I can find another problem. So a negative angle just means you rotate the opposite direction, in a clockwise direction. So here's our initial side. Negative 150 means we're rotating this way. There's negative 90. We're not quite at negative 180, not a semicircle, so we end up here. And remember, when you draw your terminal side of your angle, you always then make a right angle with the x-axis. So negative 150 means we have 30 degrees. Coincidentally, this is the same triangle that we just had because it's got a 30-degree reference angle. Okay, totally different initial angle given, but it's the same triangle. So tangent is just what we got last time. Tangent is the opposite of 30 divided by the adjacent of the 30-degree angle in that right triangle. So you'd flip and multiply, so negative times a negative makes a positive. So I get 1 over the square root of 3, which is square root of 3 over 3, because I multiplied the top and the bottom by square root of 3 to rationalize the denominator. Cotangent's just the reciprocal, so flip it, and then rationalize the denominator. Multiply the top by square root of 3 and the bottom by square root of 3. Use reference angle. Use a reference angle to write cosecant 61 pi over 36 in terms of the cosecant of a positive acute angle. Okay, positive obviously means no negative sign, so this is a positive angle right now. And acute means that it's less than 90 degrees. So pi over 2 is a 90-degree angle, okay? And this is in terms of radians. So let's see what we can do. You can convert that to a degree if you're more comfortable with that, just to see where it lands. But we know that 72 pi over 36, that would be a full circle, right? That's a full circle. So, and that's because radians is always talking about the circumference, the portion of the circumference of the unit circle of radius 1. So 72 pi over 36 isn't quite a full circle. It ends up somewhere over here. And we need it to be an acute angle. So let's see, positive. Okay. So that's the terminal side of 61 pi over 36, but we don't have to draw the same terminal angle. We just need it so that the cosecant ratio is the same. But there's no way to write this in terms of the special triangle I just showed you. The other special triangle, by the way, is a 45-45 triangle. It's way easier to memorize because if the hypotenuse is 1, these both have to be square root of 2 over 2 by the Pythagorean theorem. But there's no way to rewrite this. So let's see what else they're doing. Cosecant is the reciprocal of sine, right? And one general thing we can say about sine is that sine is positive up here in this quadrant, and sine is positive over here. And some students say all students take calculus, S for sine, and A for all. All are positive here, sine's positive here, just tangent's positive here, and just cosine's positive here. And so since sine and cosecant are just reciprocals, that means cosecant's positive here and here. Our terminal side landed in a negative spot for cosecant. So the only other place where we could draw this angle would be over here. Oh, but it says of a positive angle. So if we drew, okay, so if it's going to be acute, the angle has to be in the first quadrant up here, right? We got to be able to draw it like this. That's the only place where you're going to have a positive angle, a positive acute angle, because that acute means it's less than 90 degrees. So we know we have to draw it like this. And if it's going to be a cosecant ratio, you're going from a negative area to a positive area. That must mean that we're going to have to write it as negative cosecant and then some angle in here so that it still equals the same thing. And so to find out exactly what goes up there, it should be the same reference angle. So from here to here, how much is that? We said it's 72 pi all the way around the circle. 72 pi over 36 all the way around the circle because that's 2 pi. But if we subtract 61 pi over 36 from that, actually I just got to thinking, is this, I might have to redo this whole video. No, I'm good. Okay, yeah, I should have just drawn it more out here. 72 pi subtracted by 61 pi, 72 minus 61 gives us 11 pi over 36 left to go before we make a full revolution. So this angle in here is 11 pi over 36. for reference angle. That must mean up here it's 11 pi over 36. So to draw the same triangle so that we have the same ratios, we need 11 pi over 36. But we said because this cosecant 61 pi over 36 is in a negative spot for cosecant, because only cosine and its reciprocal secant are positive down here. That means cosecant's negative here, so we got to multiply the outside by a negative sign. So that's a tough theory question there. Okay, so this is a similar question. We want a positive acute angle. That means in the end we want an angle between these two places so that it's less than a 90-degree angle. What is the expression for secant 195 degrees? Here's 90, here's 180, 195 is here. That means the reference angle is 15 degrees, right? Because we're 15 degrees over a semicircle. 180 plus 15 would make 195. And so if you draw secant, you could use the fact that all trig functions are positive in the top right. Just sine and its reciprocal cosecant are positive up here. Just tangent and its reciprocal are positive down here. And cosine and its reciprocal secant are positive down here. So we've drawn secant in a place where it's going to be negative. Secant is only positive here with cosine, or it's only positive up here. So we know we're going to have a negative answer. So if they want to flip it and draw a reference angle over here where it's a positive acute angle, then whatever answer is, we got to negate it, because for it to be equivalent to secant 195, we got to multiply it by -1. And to find out what angle goes up here, it's the same thing as last time. 15 degrees is our reference angle. To keep the same ratio, to keep the hypotenuse divided by adjacent to be the same, we also need a 15-degree ratio. That way we're drawing the same triangle with the same dimensions. So 15 has to be the angle there, and that's positive and acute, and I think that's it. You can test that with a calculator. Negative secant 15 should be the same thing as secant 195.